Lesson 5.1 Fundamental Trigonometric Identities, Part A. Uses for identities. Identities are statements that are true no matter what the value of x. We can use them to evaluate trigonometric functions. We can use them to simplify trigonometric expressions. We can use them to develop more identities. And we can use identities to solve trigonometric equations. There are several fundamental identities, many of which we've seen before. Sine of u equals 1 over cosecant of u, and cosecant of u is 1 over sine of u. Cosine of u is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent, and cotangent is 1 over tangent. The ones that I've colored yellow, I think you should memorize. The quotient identities. Tangent is sine over cosine, and cotangent is cosine over sine. And then the Pythagorean. Sine squared plus cosine squared equals 1. These others, if you divide by sine squared or cosine squared, you get the other two. And then we have the even and odd identities. Cosine of negative u equals cosine of u, so does secant. Sine of negative u equals negative sine of u. Same with tangent, and cosecant, and cotangent. So these two are even, that's what they're called, and these ones are odd. And the cofunction identities. Sine of pi over 2 minus u equals cosine. Cosine of pi over 2 minus u equals sine. So these are the sine and the cosine. Tangent and cotangent. Secant and cosecant. Alright, so let's use some of these. If sine of theta is negative 1 and cotangent of theta is 0, evaluate cosine. Well, we know we have cotangent and sine, and we want cosine. So tangent sine over cosine, so the reciprocal cotangent is cosine over sine. Cotangent of theta is 0. Sine of theta is negative 1. Multiply both sides by negative 1, and you can see cosine of theta is 0. Let's try another one. Evaluate tangent of theta. Well, how does tangent relate to these things we have? Well, we know that tangent and cotangent are reciprocals. So tangent then must be 1 over 0, since cotangent of this angle is 0. Oh, but what's 1 over 0? Undefined. So tangent of that angle is undefined. Look at that. We did all that without even finding what the angles were. Let's try something else. Simplify. All right. Well, we know we had this tangent squared of u plus 1 equals secant squared u. So that means where the secant squared is, I can put tangent. And there's a mistake here. Instead of theta, let's use x. So that part, the secant squared is tangent squared plus 1. The plus 1 and the minus 1 will, of course, cancel, so then I have tangent squared over sine squared. Oh, hey, but wait. Tangent is sine over cosine, so if it's squared, it'd be sine squared over cosine squared. Wait, how do we divide fractions? We multiply by the reciprocal, so it'll be sine squared over cosine squared times the reciprocal of sine squared to be 1 over sine squared. Sine squareds cancel out, so I have 1 over cosine squared. Oh, but wait, 1 over cosine. 1 over cosine is secant. So 1 over cosine squared would be secant squared. Let's see, what did we use? We used that one, and we used that one also. So those are the identities we used. Let's try another one. What could we do? Maybe we could distribute sine phi cosecant phi minus, well, that would be sine squared phi. Oh, wait, what else? What's cosecant? Cosecant is 1 over sine. So those would cancel out, and I have 1 minus sine squared phi. But we have this identity. Okay, so we used, let me write it out. We used cosecant is 1 over sine. We also had this identity that sine squared plus cosine squared is 1. So that means sine squared would be 1 minus cosine squared. So instead of sine squared, I'm going to put 1 minus cosine squared. So I have 1 minus 1, and then I have minus a negative, which becomes positive, cosine squared. Let's try another one. All right, again, we had that sine squared plus cosine squared is 1. So here, if I subtract the sine squared, cosine squared is 1 minus sine squared. Notice at the top I have 1 minus sine squared, so the top would become cosine squared. The bottom, we also had cotangent squared plus 1 equals cosecant squared. So where I have the cosecant squared, I can put cotangent squared plus 1. Of course, the 1's cancel out. So I have cosine squared, and now we're doing x's, not u's, over cotangent squared. Oh, but wait. Cotangent squared, cotangent is cosine over sine. So we could make it cosine squared over sine squared. But you divide fractions by multiplying by the reciprocal. So I'll have cosine squared times the reciprocal, so it'll be times sine squared over cosine squared. Cosine squareds cancel, and it looks like we have sine squared x. Let's try one more. All right, so identities. We know that cosine of pi over 2 minus x, or u, equals sine. So that first part is simply sine of x. I also know that secant is 1 over cosine. So I have sine over cosine. Oh, but wait, I know that tangent is sine over cosine, so that becomes tangent of x. All right, keep trying those types of things using these identities to simplify today in your homework. That's all for today. Have a good day.